This is a video tutorial on some basic constructions that you will be doing with your 6th grade students. We have here our different tools. It's important before we begin that we have a sharp pencil point and also a sharp lead on our compass. And if the lead on your compass is not as sharp as you would like it to be, you can sharpen it easily with some very fine grade sandpaper. So let us begin with an initial construction that you'll be doing with your class. So we begin in the center of our page, and we will inscribe a circle with a nice sweeping movement of our compass. And then at a point above the center of the circle and on the circumference, we'll proceed to draw another circle. And then we walk over to the next point where the circles intersect, and we continue. Now, after drawing maybe the initial or the first two circles, I would ask the students to finish the drawing. So now we will continue. Keep in mind this is a instructional video for teachers, so you need to adapt this to the pace of your students. We will also not be doing any coloring in this video tutorial. I'll have comments about coloring in our live sessions. And there we go. We have divided our circle into 6 points. This is probably the first full construction you'll do with your students. You may choose to do this either in a main lesson book or when you do geometric drawing with your students, you may choose to keep certain examples on what I call a plate. So, for example, this is a piece of painting paper that I've cut into a square. You can keep it rectangular, but I would specify a particular distance from the border, and here using, in this example, Roman capitals, I would write out the title plate number 1 and its title 6th division of a circle. This is a very nice way to display drawings in your classroom or in the hallway. So these are called plates, and they would be separate from your main lesson book. Let's move on. Of course, you do not have to draw the full circles. You can just draw large arcs and you get the same results. Moving right along. So we know how to divide a circle into 6 points. In this example, I would begin by drawing the first line. And let me point out that when we draw our lines and we connect 2 points, it's very important that we line up our pencil with the points and we check before we draw the line. That way we're accounting for the width of the lead and any possible shifting that's happened, and then we draw our line. So I would draw this first initial line and then tell the students, please complete the drawing. And so they will repeat the lines around, and they'll end up with what's called a regular hexagon. And it is regular because all sides are the equal length and all angles are the same. So it is a regular hexagon. Now we can do some variations off this 6th division of a circle, such as here. I would begin by dividing the circle into 6 segments and then drawing one line and saying, I'm going to draw a line from this point and I'm going to skip a point to the next point. Then I draw my line, and then I would say to the students, please continue this pattern and finish the drawing. And this is what they'll end up with. Now here I've shown you a further variation where you can then inscribe into this regular hexagram a nested hexagram. And you can repeat this as many times as you would like. And then let's move on to this example right here. I'm going to cover this up right now so it doesn't distract us. Here again, we start with a sixth division of a circle. And the instruction here is to join every point to every other point. So I'm going to connect this point to this point, this point to this point, and then at this point I would say finish the drawing. And they'll know to continue this point to this point, and so on. And then walking around the circle and repeating the same activity. And this is the drawing that you end up with. You may want to ask your class, so how many lines have we drawn when we connect every point to every other point and starting off with 6 points? And so they can laboriously start counting all of the lines. And if they're accurate, they'll come up with 15. And then you can ask your students, is there an easier way? Is there a mathematical way of just knowing how many lines we'll end up with if we connect each point to every other point in the circle, starting with 6? Well, you may get to the place where somebody will say, well, there are 6 points. And from each point, there are 5 lines. 1, 2, 3, 4, 5. So 6 times 5. But of course, each line shares a set of points. So we divide it by 2. We have 15 lines. A variation on this is you can ask your students, all right, draw a circle and place 7 points on the circle randomly. Now, if you were to connect each of those points as we did in this exercise with every other point, how many lines will you have drawn? Well, the astute student will say, let's see, 7 times 6, because from each point, if there are 7 points, there will be 6 lines leaving from each point, and divided by 2. Right, which of course equals 21 lines. And so from there, you may get to the place of coming up with a formula or asking the class, what could be the formula? So the formula would be number of points. This is a small digression, by the way. Number of points times the number of points minus 1. Are we done? Oh, no, we're not done. Divided by 2, exactly, divided by 2. And that's a formula that they can derive themselves. Let's move on. Here, the next set of instructions in this construction is to start with the 6th division of a circle. So we have done that. And then to divide the 6 points into 12 equal points. So that means we need to half an angle, or we need to bisect. So let me show you how we do that. I'm going to set my compass radius to this, to the radius of this circle. There we go. And so we would take one of our points here from the 6th division. Here's the other point. Draw an arc. Move over to this point. Draw an arc. And suddenly we have right here enough to find the midpoint between these 2 points. And so we just repeat that all the way around until we have bisected each of these angles in effect. And then we end up with 12 division. Next, I would instruct the students to connect from a starting point, connect this point to the 5th point. So we're skipping over 4. And to continue around, right? And so on. And then finish the drawing. And this is what their finished drawing would look like. Next construction is going to be based on a regular hexagon. Okay, so we begin with a regular hexagon, then we bisect the 6 points to have a 12 division of a circle. So we've drawn a hexagon and we have bisected to get the 12 points. So the next exercise is to connect each point, or to draw a line, I'm sorry, through the center, so that we are basically drawing radii through 12 radii to the center of the circle. And the next step in this exercise is to create, well, let me perhaps go back to the next one. Once you have done this, we will then proceed to nest hexagons. So we will, for example, connect these 2 points and make our way around the circle that way. And we would repeat this as much as we would like, and we end up with these nested hexagons. Great. Now from here, we can create what is called a logarithmic spiral. And to do that, there are 2 ways. First of all, this form is called an equiangular spiral once we have colored it, because it will be based on the fact that these angles here and these angles here, these are all the same angles, right? And so on. So now, in order to create a spiral, we just continue this way. And if we were to shade these, and again here I'm just doing this for demonstration purposes, but I'm just going to indicate here, let's say we were to shade these 2 right angle triangles, and this one, this set of triangles. And if we were to continue, you can see that we are creating a spiral going inward. Then we would continue with this one and this one. And so on. And this would create what we call an equiangular spiral. Now that's one way of doing it. And we can go, we can say, well, how many hexagons, what's the maximum number of hexagons that you can make in this method? And really the answer is, theoretically, it's infinite. You can't draw the maximum hexagons, of course, in this manner. We're limited with our pencil and so on. But theoretically, it is infinite. So we can create a beautiful logarithmic spiral or an equiangular spiral. Now, there is a more economical way of creating a spiral. We can start the way we did before with our 6th division, which became a 12th division, and then we connect all the radii, draw radii from each of the points. Next, what we can do is that we are going to make a right angle to the radius, and we'll repeat that. So let me show you what that looks like. Take a little set square. Make sure it lines up with the line. And we're going to make a right angle triangle right here. Okay, and now we're going to repeat this from here. And we're going to repeat it from here. I'll do one more, and then you can finish it. So if we continue this way, if we continue to go through the middle with, if we continue to make right angles to the radius and repeat it, we also end up with a logarithmic or equiangular spiral. All right, so that's it for this video tutorial. There are many variations that the students will come up with just based on these basic constructions. Thank you.